Hello, good evening, everyone. I know it's been a long day and you must be pretty tired by now after sitting through many AI talks. So, unfortunately, this is going to be yet another AI talk. So, so thank you for making it to this session. I hope you will enjoy this session as well. In the next 45 minutes, I'll show you how we can use generative AI or Gen AI for a good cause. So that's the motive of the talk. Um, I'll walk you through a project that I've been working for some time. So the goal of this project is to help the blind and visually impaired people to see the world. So when I say see the world, it's not something about medical research or medical engineering device, but it's related to a personal assistant to blind people. So it's like a wearable smart device that these blind people can take with them wherever they go. So this device can uh, see what's in front of them, and they can speak or read aloud what's in front of them. So, so that's the idea of the project of the talk, as well as the talk as well. So generative AI plays a crucial role in this project, and it is complemented by other technology areas like edge computing, integration, and streaming data architectures as well. So keep that in mind. This is just a work in progress project. There's no end product as of now, but I'd like to share my experiences, the learnings, and the way forward that uh, you all can take note of it, and you can apply to your own personal Gen AI application as a takeaway. So let's get started. I'm Danushka, a developer advocate from Red Panda Data. Anyone heard of Red Panda before? Quick, no. Anyone heard of Kafka before? Apache Kafka? Okay, brilliant. So in simple words, Red Panda is a drop-in replacement for Apache Kafka. That means if you have a Kafka workload, or if you have a Kafka producer or consumer, you can seamlessly migrate all your workloads into Red Panda because it provides Kafka API compatibility. So you don't have to change anything in your code. Just a few configurations, you can get Red Panda up and running. In the context of Gen AI, Red Panda and its ecosystem of tools will help you build fast, real-time data pipelines that can collect data from your organization and feed them into LLM models, so that the responses you get from LLMs will always keep fresh, relevant, and accurate. So that's about Red Panda, and a little bit of myself, background. I'm coming from a enterprise integration middleware background, and I have some specialty in real-time analytics. Uh, so at Red Panda, I help people with people building large-scale event-driven applications and streaming data to explore more with their applications. If you have any questions related to streaming data or this talk, please feel free to connect me over LinkedIn. Also, you can follow my writings on Medium as well. I'd like to begin this talk by sharing a personal story with you. So, when I was a kid, I had this uncle who became blind due to a tragic accident at his workplace. So, after becoming blind, he used to live alone at his place. So, he didn't have much visitors. So, I was the only visitor he hardly get. So, when I returned from school, I used to visit him in the evening, and then we used to observe the sunset while sitting at this bench at his garden. So, while doing so, I was narrating, or I was describing the scenery around us. Like, okay, now the sun is turning golden, now the sky is going orange, and things like that. And then I could see the genuine smile on his face, and he was so happy because he couldn't see it in real life. So, so that was the main idea or the inspiration I got. Uh, Time flew fast. I grew up, my uncle passed away, and soon after I graduated, I tried to invent some kind of a technology to help people like my uncle, because there could be something like millions of people like him, so they would love to have a human companion with them everywhere they're possible. they would love to read to them and describe what's surrounding in there, so they can't, because they can't see what's in front of them. So having that idea, after my graduation, I tried to build some kind of a image recognition and classification application. So this was precisely 15 years ago. If I go back, this was 2010 or somewhere. At that time, big data was booming. It was at its dawn, and there was no reliable machine learning frameworks like PyTorch or TensorFlow. There was nothing. And there was no IoT either. So everything was in the early stages. So I tried to build things by my hand, and I tried to create a machine learning model by myself. And then I soon realized that this is going to be an upstream battle. So I gave up because it was so complicated. And as a fresh graduate, the technology wasn't accessible and affordable for me. So I put the project in the back burner and I moved on. And then this generative AI became a phenomenon, popular thing, back in 2 or 3 years. So now everyone knows generative AI. Raise your hand if you have heard of or if you have worked with generative AI framework. Okay, I see mostly good number. So for those who are new, or if you haven't heard of generative AI, I'll put it in simple. It's a technology that allows you to generate new content by giving instruction to specially trained set of machine learning models. So we call these machine learning models large language models, and they have different sizes in their parameters. The beauty here is you can give these models can understand natural language instructions, and they can process them, and they can also respond back to you in natural language. So that's generative AI in a nutshell. With Gen AI, you can do things like you can classify text, you can summarize emails, you can extract bullet points from lengthy blog posts, and so on. I'm pretty sure you all are familiar with this, with that. Now, the true beauty happens with the vision capabilities of these generative AI models. For example, vision capabilities means these models can see, understand, and they can reason about the visual elements we pass on to them. Visual elements as in, this could be images or videos. So they can understand them, and we can do some cool things with them, like we can ask a model to describe an image, the simplest case. Or we can pass a video and ask it to narrate the video with Morgan Freeman's voice, something like that. So few cool use cases. And then also we can ask a model to auto-generate a caption for an image. So we could populate e-commerce catalog or something. So these are like practical use cases. In this case, if I give this model the Eiffel Tower and ask it to narrate it, it will come up with something like this, you will see. By changing your prompt and by adding it more specific instruction, you can control what you get as the response. You can also control the length or the verbosity of this response by limiting the number of tokens you pass. If I go back here, almost all the LLM vendors and hosted platforms now they have announced their support for vision AI capabilities. For example, OpenAI, we have OpenAI 4.0 model. With Llama, Meta, we have Llama 3.2 supports vision, and Claude 3, and the list goes on. All right, now let's quickly see how we can work with this kind of vision API capabilities in your application. So what I'm going to do is I'm going to send this photo into a Python script and then ask it to describe it for me. So basically this is me and my friend, my co-speaker, Mark Needham. So we spoke at DevOps London a few months ago. So I'm going to pass this image into OpenAI 4 and ask it to described it for me. So basically, this is my Python code. I know most of you are coming from Java background, but the same principles can be transferred to Java if you use a framework like LangChain 4j. So it's pretty straightforward. But I'll quickly walk you through the high-level steps you could take. So basically, I'm going to use OpenAI 4.0, so that's why I need this OpenAI API key. And then I have a function here, if you can see here. So this function encodes an image, local image. So in this case, the local image resides in my local hard drive, but OpenAI expects it in binary format. So I had to encode it in base64 format. Otherwise, you could host the image in somewhere else, something like S3 bucket, and pass the URL so that model can access it over the internet. And once I have that, I formulate the request headers, authorization, and I formulate the payload here. I'm using GPT-4o Mini. And then I add my prompt. So this is a default prompt. This is basic, simple prompt, but you can customize it. And I pass the image URL. And I set the maximum number of tokens that should be included in my response. You can tweak it further. And then I get my response. I made a request to the endpoint, get the response, and try to print the description. Let's try to run it and see. So this is anyway Python program. It will take some time, usually around 2 or 3 seconds. It depends on the US. So this is the description you get. So basically, it's how the model sees the image. So it says two individuals standing at a booth with a backdrop. So basically, it's pretty much accurate. I wouldn't say it's 100% accurate, but 80% of the time, the model got it right. So that's the basis of how you can work with the vision capabilities of these LLMs. And then moving on to my presentation. So basically, in the last example you saw, I was able to write a simple image recognition program within few lines of code, Python code. But if I were to do that exactly 15 years ago, I didn't have that capability because the technology was not right at that time. So there was lots of boilerplate to do, and there was a lot of energy barrier for me to make. But today, with the help of generative AI, it made AI accessible and affordable to me. Like I'm like an average developer. I don't have a strong background in machine learning or statistics or mathematics, but I was able to get this thing done by using my integration capabilities as well as some data analytics capabilities. So all I was doing was I was piecing together all these model capabilities into a single solution. So I hope you could do the same with these models. So having that capability, and I was too excited, and then I took my old project, and blew a fresh breath of air into that, and then I restarted working on it. So this time I was planning to build a personal assistant for blind people. So essentially, this will be something like a portable device that blind people can take wherever they go. So essentially, this device should have a camera to see the outside world and some kind of a triggering mechanism. So that's where this green color push button comes in. And then integrated speaker so that the device can read aloud, speak to the blind user, so that they can hear. So ultimately, this device can be made wearable by attaching it to some kind of a vest, so that a blind person can wear it and they can take it wherever they go, and this can come up with its own power source connectivity as well. Now let's try to see what's inside this device. Before that, let me walk you through 3 design goals I made, design decisions I made designing this device. So these are like 3 first principles. First thing is the device must be able to speak back to the user, because based on the studies and researchers, uh, it's known that blind people can hear really well. They have enhanced audio cognition capability. Uh, if you happen to see a blind person, they use this walking stick, right? When they walk, they use this white. What they do is they try to hit the ground and they try to make a noise. Using that acoustic feedback, they try to gauge what kind of a environment they are in. If the sound is not familiar to them, they avoid that dangerous area. So that's how they navigate. I know it's pretty uh, primitive, but let's see how we can make it improved. Uh, so that's one. So the requirement is the device must have the ability to speak or read something aloud to the user, so that the user can hear it and act accordingly. Second decision was this device must be practical and pragmatic, so that the people can use it in their daily lives. The problem with most blind people are they lack social inclusion, because they lack the confidence in their mobility, because they are restricted in terms of their navigation. They used to live in solitary spaces, like confined to their homes, or restricted to their care homes or hospital or specialized facilities. So in order to take them out of these comfort zones and make them comfortable navigating through the real world, we need to make this device portable, maybe wearable, and self-contained with power. So it shouldn't be something like attached to a desk. So it should be something like a smartphone they can take. But smartphone can be tricky, because and then comes the interaction. So when interacting with this device, it must present the user less number of options. Ideally, preferably touch options, because blind people can do touch operations really well. And we can also do embossed braille letters like that, so that they can uniquely recognize what action needs to be taken. So that's why I added this push button to that devices. And also, we need to make it affordable, because many blind people, they live and they financially depend on other people, like their family, government, or any non-profit organizations. But so if I make this technology widespread and popular among those people, we need to make it affordable to most of the people. So those are the design decisions, design principle I used while designing this device. So let's tear open this device and see how it works. So if you see this schematic diagram, so that's how this, at a very high level, this is how everything works together. So we have a camera, a push button, and an integrated speaker, and then we have a LLM. So in this case, OpenAI, hosted in internet. So device must have a reliable internet connection. So that's how this communication happens. So this is how the sequence of event happens. When the user presses the push button, what happens is the camera takes a photo and save it to the hard drive of the device. So, and then there's a software program running inside this device. I'll take you into that shortly. For now, just consider this program can read this image and send it to the LLM. So this happens over the internet. And then the model can, so with that request, I pass a static prompt, like a system prompt. So the model can now, it can describe the image, and the image description is passed to the program in text format. In practically, it's in JSON format. And then the missing piece is this text must be read aloud to the user. So in order to do that, Uh, so the image description is generated, and the final step is uh, image is narrated to the user using TTS or text-to-speech module. So that's a final piece of the puzzle. Hope that is clear for all of you. So when it comes to putting together everything as a integrated solution, there were a few approaches I considered. So ultimately, I ended up with two. First approach is building a smart device with some kind of a smart device framework like Raspberry Pi. I know it's pretty unpopular framework, a road less taken, but I considered it. The alternative was building a mobile application on top of a good smartphone platform. So that's the second option. I will explain you why I went ahead with Raspberry Pi. If you, I'm pretty sure you are all familiar with Raspberry Pi. So Raspberry Pi gives us a good solid foundation to build this kind of portable computation devices. So ultimately, Raspberry Pi is a reliable and more popular and affordable platform to build smart devices. And also it provides a good performance per price. So, for example, if I consider Raspberry Pi 5, the latest one, you could buy this board with 8 gig of RAM and quad core processors for like less than $100. So in the UK, it is like £75. So that's pretty much affordable, and it comes with all the bells and whistles you would expect from a portable computation device. Like we have USB-C power supply, and that's really nice when it can make him portable. And it comes with USBs, gigabit Ethernet, and everything. Uh, Practically speaking, we are not going to run a model inside it. We are just going to inference it. So we don't need fancy GPUs here. But I'll come to that part later. But for now, in order to make a request to our internet, we can just live with quad core processor. So that's it. And device is not just sufficient. So we need to add vertical modules on top of it and make it an integrated solution. So we need a camera module, which is already available in the marketplace for few uh, affordable price. And then we need a communication module. So this is like a GSM module, can fit in. And then the push button, easy to fit in. And then an integrated speaker, or we could plug into an earphone, so in case of a noisy environment. And then to make it portable, we could use a power bank. So these are like Lego blocks you can assemble to build the final solution. So now the hardware part is sorted. Now what's up with the software part? I know, as I stated, Raspberry Pi is a solid foundation, and it comes with a operating system that is Unix-like. So it's pretty flexible. For a developer like us, you could pick and choose the technology you want to build your application. In my case, I picked Python because I'm mostly fluent in Python. But if you are familiar with Java, it doesn't matter. You can run your program in Java as well. So basically, regardless of the technology stack you pick for programming, this is going to be the structure of your program. So when the user clicks the button and the camera gets activated, and the photo will be taken into a hard drive, and then the program can read the image, encode it, and send a response, and get the response and convert it to text-to-speech converter. So if I put together the data flow between all these components, it would look like something like this. It's quite straightforward at this point, but this can be tweaked as we move along with the project. For now, I'm using a local image, but if needed, you can store the image in a cloud, something like a S3 bucket somewhere, and you can use it. But for now, to make it simpler, I save the image into my device. All right, now let's see a prototype version of this code. This is basically an extension on top of the previous code I showed you. What it does differently is I wrote a simple TTS function. So basically, when I pass a random text to this function, it can read it aloud. So in order to do that in Python, I use this PyTTS x3 module. If it is Java, you could use any relevant package. So this is pretty much solved problems in this space. It's not a challenge or new challenge to solve. And then I use the encode image function, and then pretty much the same structure of the code. Now let's try to do. Finally, I get the response. This is where we stopped last time, and then I pass it to the text-to-speech function. Now let's try to run it. Might take a little time this time, because we have multiple hops of communication. It goes through internet. Let's wait.
The image shows two individuals standing in front of a booth for Rib Panda, which is noted as a proven Kafka alternative. The booth
So that's the prototype. That's a minimal viable product, MVP. I just killed that program because it's going to read the whole thing. But you can customize this voice. There are brilliant AI libraries, frameworks that you can have more natural human-centric noise to these text-to-speech engines. So it's up to you to tweak it further. Right. So that's the basis of this program model. And then I mentioned I had an alternative with a smartphone. So why would I choose a smartphone? Because it's already an established platform, because it has all the modules I showed you has built in. It has camera, storage, connectivity, good performance. If you consider an iPhone, it has GPUs even, self-contained power, audio, and everything. And if you're familiar with this Siri shortcuts, I'm biasing towards Apple this time because I have an iPhone this time, but this could apply to Android, Google Assistant as well. We could easily get rid of this push button here, and we can substitute it voice commands. For example, not sure whether you have heard it, but if you say, "Hey Siri, say cheese," this iPhone can open its back camera and take a picture and automatically save it to your recent photos. And then what left for us is to develop a mobile app to analyze this image and send the narration done. So that's the approach with the mobile app. But why not? Because there are a few concerns. So ideally, I would love to start my solution on top of a mobile app, but the thing is, in order to have a mobile app, the thing is it's expensive. Not everyone can afford a smartphone like iPhone, or at least a phone with good performance. And then using this iPhone or working with this mobile device for a blind person, it's quite complicated. There are many hoops in navigation. It's not like touching few buttons. It's all about touching this thing and going through multiple navigation steps. And so almost and also we have to rely on the mobile manufacturer's specification and its AI capabilities. So there's a hard limit for us. So in case of Apple, it could be Apple Intelligence. We can't go beyond that. So those are the restrictions. But that's an option as well. You could try that out. So that's why I chose to go ahead with Raspberry Pi, because it's flexible. It comes with its own OS. It's Linux. End of the day, you could mix and match what the technology stack you want to build. And it's affordable. Everyone can afford it, and also offers reasonable performance. So as I said, we are not going to train a machine learning model inside it. We are just going to infer an already trained LLM. So for that, we can be happy with the CPUs that it has. Now, even with Raspberry Pi, we can try to push it to its limit. So basically, I'm trying to make it more affordable by using open source local LMS. So basically, I'm trying to run these LLMs inside the device, Raspberry Pi. It is not tried yet, but I'm getting there. So basically, the idea is, if you are working with a cloud-hosted or vendor-provided LLM, then the vendor will going to charge you based on your usage. The higher number of tokens you use, you will get more accurate response, more timely response, but the response of your bill or your usage cost will also will rise as well. So for a scale to make it scalable and sustainable for disabled and blind people, we need to make it more affordable and economical over the long term. So that's why we could experiment with this local LLM providers like Olama. So basically, if you consider Olama, then we have open source vision models like Llama 3.2. It has the vision capabilities, so we could try to deploy it there. It will be slow because this Raspberry Pi doesn't have GPUs, but over the time, I believe there will be more devices like this Raspberry Pi with more computational power and more GPUs. I know Qualcomm is working on certain things. So there's this whole concept called in-device AI. So that means AI is coming to your devices, and it has already arrived, and device manufacturers are making it more faster and affordable in the future. So we could leverage some kind of a device for that. So why working with local LLMs are good? Because it has a reduced latency. That means you are inferencing the model locally. So there's no need of having centralized internet communication there. Your responses will be pretty faster. And it's free. There's no limitation of context tokens you can utilize. And also, as an added advantage, it provides data privacy and sovereignty. And if you are distributing this device in a certain sovereign region, your data will not go outside that region. You can be assured with that. The drawbacks would be the performance, because running this kind of a model, LLM, with vision capabilities, that means the model should be like maybe medium size or large. That means 5 or maybe 7 billion parameter models. So it's really challenging to get that into a Raspberry Pi, I know. So the performance will be a bit slow at the beginning, but over time, I believe we can overcome that problem as well. I'm pretty sure LLMs will be optimized, and the hardware will get upgraded as well. They will get affordable GPUs as well. All right. Now let's see how we can make it a part of the ecosystem, and how we can make it scale out so that we can have a bigger impact on the society, so that we can include more disabled people and make a big technological impact. So basically, the idea is to build an integrated monitoring solution by combining this device with the rest of the ecosystem components. So this is where we talk about the bigger picture. So, and this is where Red Panda, Kafka, and a few other components come into play. So basically, individual devices works well as expected, but if we combine these devices together, and if we federate them together, we can have a more productive or more effective solution at the macro level. So for example, we can improve this device to stream live video feed from the patient or the user who's wearing it. So instead of pushing a button, we can always have it stream back to a server. So this server could be running on some kind of a non-profit organization, NGO. So they could run local LLM server. And these feeds can be fed into these LLMs. And these LLMs then can look at these video feeds or photo feeds, and they can detect anomalies. For example, if a patient crosses some defined geofence, we can trigger an alert because it's off limit to them. For example, uh, if a patient falls off, or if a patient is nearing some kind of a dangerous or hazardous location, we can warn him in real time. So those are the use cases, additional use cases we can build on that. And the beauty here is these local LLMs can talk to this software stack. So what you see here is the business or the logic you can program. So this could be your microservices, or could be your lambdas, or can be anything that has the logic to react to these function calls. LLMs can call functions, and we can chain them together like a framework like LangChain, and we can build some kind of orchestration. And then these orchestrations, they can fire events. And these events can be collected into some kind of a streaming data platform, something like Red Panda or Kafka or anything with the similar capacity. And then further, this data can be processed with some kind of a stream processor or stateless stream engine, something like Red Panda Connect, can do optional data massaging, transformation. Also, Red Panda Connect can provide sources and data syncs to external systems so that you can pull in more data, build real-time RAG application pipelines, and then use it for downstream consumption. For example, we can always build a real-time 360 view of a patient. For example, I'm getting this video feed, and then I can also get his heartbeat from his wearable, and then I can also pull in his medical record from the hospital record or some kind of a system of records, and I can project that in a monitoring dashboard. So that could be used by the care home authorities or some kind of a people who will be monitoring these patients. So this kind of a ecosystem will always make sure these disabled people will get their needed help whenever they are needed, and they will be watched by someone in the sky. So, right. So potential use cases could be anything that based on live video streaming and live photos. So remote patient monitoring can be one, and then we could extend this use case to a few other areas where we could also facilitate people with normal vision. So for example, this could be an AI-assisted co-pilot for firefighters who are working in a low visibility environment. When they are firefighting in a smoke-filled environment, this could be a good addition. And then this could be a personal assistant to the elderly people, because with the press of a button, this device can summon some kind of a activity, or this personal assistant can they can narrate a scenery, and why not we can make it write a song and sing a song as well. So there are possibilities. And then this could be an AI-assisted body cam for rescue workers, and we can augment it with AI augmented heads-up display as well. So there are many potentials. So this is just the starting step for the project. Just to wrap up what I've been discussing. So, blind people need a practical and affordable solution to make their lives easier. They lack social inclusion these days. They need a confident mechanism to navigate and included in the society. So, and then image recognition and classification used to be a hard topic, difficult area 15 years ago. But now, today, with the help of generative AI, it is accessible to many developers, average developers like me. So it's just a few lines of code, and you will start building more interesting and more creative multimodal Gen AI applications. And to make it scale out and make it to make a bigger impact on the technology ecosystem, we can bring in more advanced technologies like Red Panda and its ecosystem to make it integrated monitoring solution, so that we can make sure all the patients who are wearing these devices, they will get their help whenever they are necessary. So that's the idea of this talk. If you are eager to learn more about Red Panda, so I recommend you Red Panda University. You can go and check out. So there are few self-paced online learning materials about streaming data, how you can build Gen AI application by incorporating Kafka or Red Panda. So there are a few resources you can check out. Yeah, that's it for now. Thanks for joining, and thanks for making it so far. I can take few questions since we have few time. Thank you. Question? Yes.
Yes. Why a large language model? Because if for the base application, the task that is needed is to translate image to text, a specialized model that can only do that would be much cheaper to run locally.
Yeah, that's a good question. I mean, large language model means it's the accessibility. That means you don't need additional machine learning expertise to begin with. So I think that's the first step in getting the first foot off the ground. So it's easy and it's accessible for many developers. So you don't need strong background in machine learning. But you are right. I think if you have specialized models with NLP capabilities, I know you can use it straight away, but you need to have some kind of groundwork to be done. Uh, Hope that answers. But we can, when ongoing, when the project evolves, we can always evaluate different model approaches. We don't have to be tied to a specific large language model. Yeah. Any questions? Yes, please.
Did you test it on users, or is it just theoretical now?
No, this is just this is on my running in my laptop. So I'm trying to bake it into a Raspberry Pi first, and then try to do some researches on users. So I'm in negotiation with, in discussions with some care homes in UK. I'm originally I'm coming from UK, so I did my research from the feedback based on the care homes, and especially the places where the elderly and blind people live, especially the people who went blind because of diseases like glaucoma. So they lack this kind of devices, and they really need this kind of devices or mechanism. So next stage would be user testing. So it could be that. Yes, please.
Did you use an LLM or train an LLM module to identify threats? Use it locally in the Raspberry Pi as just to be fast and notify the patient?
Yes, that's a really good question. I think I missed that point. So basically, we can fine tune an LLM so to detect threats. I mean, you can write. For now, we can write a prompt. We can customize our prompt so that we can ask the model to warn us if there's a potential threat. If the user is walking towards some kind of a hazard, we can ask the model to warn. Like, say, we can ask it to, maybe we can trigger some kind of a function. The LLM can call functions. But if we need like more specific threats, like falling down or something like increased heart rate or some kind of things, then I think we can isolate and we can fine tune the model to these kind of problems. I think that's the future direction I think we should take. And it would be easier with local LLMs. Yeah, that's a really good point. Okay, and if there are no questions, I think we can wrap up. So I'll be around here. So if you have, feel free to catch up. So thank you for making to this talk. I really appreciate it, and you have a good evening as well. Thank you.
Genesis sequence.